Taylor and Maclaurin series. So far, most of the series that we study are special series. We can derive them from the geometric series or from some other special series. The goal is to find the power series representation for any function f of x, if possible. To do this, we suppose the function f of x can be represented by a power series whose center is at x equals a with the radius of conversion positive r, so that the interval of convergence is a minus r, a plus r in an open interval. The function f of x is therefore the series as n go from 0 to infinity c sub n x minus a to the power n. When n equals to 0, c sub 0. When n equals 1, the term is c sub 1 x minus a. When n equals 2, c sub 2 x minus a squared, plus so on. Then we differentiate this series for the function f of x term by term, and we evaluate them at x equals a. f of a is c sub 0. f prime of x is c sub 1, c sub 2 x minus a with the coefficient 2 in the front, 3c sub 3 x minus a squared, plus so on. And so f prime of a is c sub 1. Then the second derivative, the derivative of c sub 1 is 0. The derivative of 2c2 x minus a is 2c2 plus 2 times 3c3 x minus a, plus so on. So f double prime of a is 2c2. f triple prime of x is 2 times 3c3 plus 3 times 4 times 2 times c sub 4 x minus a, plus so on. f triple prime of a is therefore 2 times 3c3. Recall that n factorial is the product from n to 1, all integers. Therefore, the n derivative of x is 2 times 3 times dot dot times n c sub n plus 2 times 3 times dot 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 all the way to n plus 1 c sub n plus 1 times x minus a plus dot dot dot. The n derivative evaluated at x equals a is therefore 2 times 3 times dot 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 times n c sub n. This is n factorial times c sub n. Isolating c sub n is therefore the n derivative evaluated at x equals a divided by n factorial. This is called the Taylor coefficients. And so f of x is f of a plus f prime of a over 1 factorial x minus a plus f double prime of a over 2 factorial times x minus a squared plus dot 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 plus the n derivative evaluated at a divided by n factorial times x minus a to the n plus dot dot dot. This is called the Taylor series of the function f at a, or about a, or centered at a. Let's summarize the result. Taylor series expansion. If f has a power series representation or expansion at a, that is, if f of x is the sum at n go from 0 to infinity of the coefficient c sub n times x minus a to the n with the radius of conversion r, then its coefficients are given by the formula c sub n equals the n derivative evaluated at x equals a divided by n factorial. For the special case when a equals to 0, the Taylor series becomes f of x equals the sum the n derivative evaluated at x equals 0 divided by n factorial times x to the n, f of 0 plus f prime of 0 over 1 factorial x plus f double prime of 0 over 2 factorial x squared plus dot 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 plus the n derivative evaluated at x equals 0 divided by n factorial x to the n plus dot dot dot. This is called the Maclaurin series. It is the special case of the Taylor series.